Hello everyone. In this video, we'll learn everything about the basics of programming, which a beginner should know to start any languages. And in this way, our main focus will be for C++ only. So let's start with it. In the last video, I had shown you how to connect our VS Code and MinGW or MySys to MSys2, where at the end I showed you how to print hello world, but I didn't tell you about the structure of program, like how I had written the code and what all are there. So in this video, we'll learn everything about that. So first of all, if you write any code, the first thing which comes is your header. Header should come at the top. Now, what is a header? Header are all the libraries which we use to import, and in these libraries there can be multiple functions that, like, there can be your input output functions, there can be some algorithm, or there can be various data structures. We use headers at the top, and the header which I had used was hash include, like the header I had used was this IO stream. All right, and to import any header, we need to use this line, which is hash include IO stream, like hash include and any library. This is the library which I had used yesterday, and this is used for your input output stream, like to take inputs and to return your outputs. And this is the syntax which is used to import them. All right. And the next part I had used was namespace. Like I had written using namespace std. Your namespace, like if I try to explain you what is this std namespace, then it is something which we need to write before all of, like, whenever we use something which is in any of the libraries, then we need to like use this std to distinguish them. All right, so if I don't write this line, then before every data structures and any algorithm which is using these libraries, I will have to write this dot dot std dot dot. All right, so to avoid writing like these repeat like a number of times, we simply say using namespace std so that we can directly use them. All right, so these are the headers which we need to include. Now comes the main part, which is our body, right? Like we have imported all the headers we need and everything, but we need to write some code, right, to implement anything. So the code comes in your int main. So whenever we want to write something, it is enclosed in this function called int main. This is your int, which is your return type, and then your main function, and this is enclosed by two brackets, and like it has two brackets after it, and then curly braces. Now inside this curly braces is whatever we write, and all the codes we like whatever we write, so everything inside this will be executed. So this is our the first function which is executed in any code, and like our execution starts from here only. Like even if you write anything else, the execution will still start from int main. All right. So now comes what do we write inside this int main function? Okay, so let's make another page. All right. So okay. So suppose I had, okay, let's write this int main here. Now suppose like yesterday, like in the last video, I had told you how to print, right? So let's try to print it here only. So what do we do to print this something? Okay, so to print something, in the world of programming, we see it as output, right? So to take, like, to show output, or to like to give output, we what do we use is cout. This is this is uh, the syntax for printing something. Like we simply say cout, then there are two arrows, like, yeah, two left arrows, then whatever you need to print, and then a semicolon. Okay, so this semicolon, like, now there are two things. First one is this is your like method to print something, which is cout output, and there is this semicolon. Now what is this semicolon, or what does it has the significance? So your semicolons are important in C++. Like there cannot be anything executed without these semicolons. Like these show the end of your line. So whenever we write something, anything in a line, we always have to add a semicolon after that. This semicolon ensures that okay, this is the end of this line, and like the execution will then now proceed to next line. If you don't add a semicolon, then you'll find some errors. All right. So this is for output, but yeah, we forgot to take input. Like okay, we are printing something, but how do we take an input? So to take an input, we use cin. So this is for output. C out. Now for input, we use C of in. All right. So C in and the arrows get inverted. C in like this is for outwards and this is your inwards array. So C in invert arrows. Now C in and in whatever variable or whatever something you need to take inputs, you write it after and simply a semicolon. This is for your input and this is for your output. All right. So now let us see how we like printed your hello world again. Let's go back to this code. Now here is our library which is used for input output stream. Then comes your namespace std, which is like which helps us use all the like anything from these libraries without including dot stds. And after that, this comes your main part, int main. After this, your main body starts. And this line prints your like your hello world, like whatever we had written here. Okay. So now comes two more things. The way we print and this endl. Okay. So let's go back to here. So if you want to print some statement, okay. So if you want to print something, statements like okay. Let me say this. This is C++ course. So whatever you want to print a statement or something, this needs to come in this inverted commas. So yeah, so, to print a statement, we need to write them in like in double quotations. All right. So next thing which we saw was this indel, right? Like what is this indel? So suppose if I try to write, okay, let me show you something to like understand this indel. So suppose what if I write after this hello world, then I suppose I write simply C++. All right, hello world C++. So do you expect it to print like in one line hello world, then in another line C++? So let's try to run it. We'll open this terminal, new terminal. Then we simply have to okay, let, let it load. Yeah. Then we simply had to write G++ O, then the name of your exe file which you want to make. Let's name it at temp hello.cpp. All right. Okay, hello.cpp does not exist. Okay, let me try to save this once into to C++. All right. G++ minus o temp. Okay. Yeah, I had spelled this hello.cpp. So now there's the creation of this exe file which we require to run. Okay, yeah. My exe file has been successfully created here, temp.exe. Now let's try to run it with /temp. And yeah, so now see what are we printing? We are printing hello world then C++ next to next. But what did I say? Like were we expecting it to print hello world and C++, right? Like what I was trying to print was hello world in one line, hello world. Then in another line, I wanted to print C++. But we saw that okay, if I try to print like if I try to print in line together, then they like after this they are printing together, right? Or okay, let's do another thing. So suppose if I try to write another print statement, say C out, then C++, then a semicolon. Do will they print in another line then? Let's see. Control S dot slash temp. No, they still didn't. Okay, yeah. I'd have to compile it again. Alright. So yeah, this is a tedious task. I'll tell you how to shorten it. /temp. Yeah. So again, so even if I write the statements in different line, they are still being printed together, right? So to avoid that, cause your C++, what does it try to do is after it prints something, it will print in the same line, like it It goes line by line. So to print something in another line or to go to other line, we simply have to add this endl. So this what does this endl does is it like it takes us to your another line. So if I try to print now let us say C out hello world. Now if I try to print C out C plus plus, so now it will take us to your new line. Okay, so for that now, okay, yeah, you can see that this is taking too much time. So let's add some extensions. The VS Code has these several extensions which you need to download. First one is your this C++, which you need to run your C++ file. I think I forgot to tell you about this in last video. Then another thing which you can download is your CPH Judge. Yeah, this one, CPA Judge. So after you can simply just download it from here, and like this makes your running easier. So then it will be added here, and now you just need to create a problem, and you can simply click on run here. If you want to take some input, you can give the input here and the expected output here. So let's try to run it. Okay, let's see what we get at our output. Yeah, now you can see that we have successfully get this hello world and C++ in your different line. Okay, and okay, yeah, another thing is in the structure of your basic structure of program, you might see in various your codes or other like platformer codes, you can simply see there is always at the end of your any program or any function, you will see this return zero. So what is this return zero is? Well, so there is some this return function, and what does it do is, if you even if you are in some function or somewhere, this return after like after your program encounters this return, it will simply end the execution of that particular function. So if this return is in your int of main, then it will like simply after encountering this return, it will end the execution of this particular program. All right. So let's proceed to our next topic, which is variables. You see that while taking inputs, we were storing whatever input we are taking in some variable type thing, right? So to getting more into variables, what are variables are? Variables are memory storage location where we can store our data, and whatever data we have stored, we can retrieve it later on, and even we can manipulate that data also. Okay, and there are other thing also like constants. In constants, we can store data and retrieve it. And once we have stored a data in constant, we cannot change it at any point of time. In mostly we use variables like so that we can manipulate it any point of time. But we also use constant for constant like pi. The value of pi cannot be changed, right? It is always 3.14. So for that those values we always use const, and the declaration for each type is for variable it is here comes your data type, then comes your name of variable, then comes your value. Here comes your value. Here is your data type, then comes your name, data type, then comes your name, then comes your value. So if I have to like store my age in a variable, so I would define as int and the name of variable, which I can say age, and the value. Suppose it's 20. All right. So this is how we use a variable, and using constant is just like similar to variable. We just add a const before your data type. So for like for a constant, I'll say const and int like the data type and the name. So if I am using pi, if I'm saying pi, so this is the name of my variable, and then comes a value which may be 3.14 and obviously the semicolon. All right, so this is how we like use your variables and constant, the basic syntax for that. Now before going forward, we'll also learn like what are the rules for naming your variables. There are certain rules while we name our variables which cannot be overlooked. So let's see that. All right. So there are around 6 to 7 rules. So the first rule is that like a variable can only start with a letter or underscore. All right. So if I say that I have to name any variable, so either it can start with a letter, uh, which can be anything from A to Z or capital A to Z, or underscore. Anything except that is like it will give you error. If you even try to use a number at the first, like at the first place, it will give you an error. All right. This was our first rule for variable naming. The second rule is that if like we can use numbers, digits, and letters like an underscore in our variable naming. So my variable name can be ABC, it can be ABC1, it can be capital ABC, it can be underscore 123. These all are correct variable naming. Third thing is we cannot use any reserved keywords. Now, what are your reserved keywords? Like we have talked a bit about our data types, right? Before, like int or char. So we cannot use them because they are already like reserved for syntaxes and all. So if I try to say that int of int, it is a wrong variable naming because int is already used. Int is already referred to as data type. So if you try to use int or something like for your variable naming, so your compiler will treat it as a like a keyword and it will give you an error. All right, so another thing is you cannot also use any special characters. So if you try to name a variable like abc alpha or like abc at the rate or abc hashtag, it will be considered wrong because you cannot use any special characters. And another thing is it is case sensitive. So like if I say ABC and if I say ABC, even though you can say the alphabets are same, but these both are different variables due to being case sensitive. It we use here like small letter, and here we are using a capital letter, so both of them will be considered different. All right, so these both will have their own separate memory location. Next one is your no space allowed. So if we cannot define a variable with spaces, so if I say int my age, it will be considered wrong. Why? Because we have added a space. Whatever comes after this data type, that will be on your variable. If you add any space, then that will give you simply error. All right, and if you want to just like if you want to connect them, you can use underscore in between. That will remove the need of space. So mainly we use underscore for that purpose. All right. So that was for the rules of variables. Next, we'll go and see what are the data types. Like we have learned about int till now, yeah, but there are a lot of data types which we can use. Like, so let's get to it. So there are around 8 types of data types. First one being your bool. Now, what is a bool? As the name suggests, bool can store your two data. First, in like it is a of boolean type. So bool, what does it store is true or false values. So if you have to name if like if something is true or false, you use a boolean, and it consists of your 2 bytes. Like you can store only two things, so it has like 2 bytes. Of shit. So as you can see, we have around 8 types of data types which we can use in C++. First one being your bool. Now the size of it is of 2 bytes, and we can store here true or false values. In C++, like okay, if you say true, then in C++ you can also store one as true. One is like if you either store true or either store one, these both are considered same. And you can also store false here because if there is a true, there will be a false, and for the false value you can also store zero in for that. And next one is our character. It also has same number of bytes as boolean, and you can store any characters in it like simply a b c anything, or capital A B capital C, or any special characters. You can also store at the rate or hashtags in your char type. Short is short is used similarly to int, just there the difference is your it consists of lesser number of elements. Like if your see here, your int has 4 bytes. All right, the total bytes int can store is 4. That is approximately from minus 10 to the power 9 to 10 to the power 9. All right, this is for int. So if int can store minus 10 to the power 9 to 10 to the power 9 numbers, your short can store a lesser number of lesser range of numbers. And similarly, after int, if you see for the same type, we have these two, long and long. It has around 8 bytes of storage, and long usually we name it your long type, and in long we can store around minus 10 to the power 18 till your 10 to the power 18. All right, this is the range for your long. Then comes your float and double. Now we have stored your character, we have stored true false values, we have stored your integers. Now comes your decimal, right? Of course, integers, if you try to store your decimal value in integers, it will not store anything after your decimals. All right, so if I try to if we want to store decimals, then we have to do that in float or double. A float can store your data like this. Suppose I can store 10.90 in float, and similarly in double. Just the difference between float and double is double can store more more decimal values than your float, as it is of 8 bytes. All right. So now let's move to how your variables are stored in your memory. So next we'll do that. So let's open another page, and yeah, let's do here. Okay, all right. Let me change my marker. Yeah. So as I have told you in my first video that the computer understands only binary language. So anything you want to store a number or a character, everything is converted to binary. Now let's see how your integers are basically converted to your binary numbers. So suppose if I have a number like suppose if I take a number, for example, say, 6, all right, and I have to convert it to your binary. I'll convert 6, and suppose I'll convert 19. I'll use these two numbers to convert to binary, and then I'll convert them to decimal numbers. Before that, I want to tell you about something that uh, if you are using an integer type, all right, if you have an integer type and you want to store decimal, then like suppose if you are dividing something, suppose if I'm saying 15 by 7, all right, so what you'll say, okay, 15 by 7 is simply what, uh, okay, suppose I'll take a smaller number, I'll take 15 by 2. You will say, okay, 15 divided by 2 is your 7.5, right? But what happens is in your integer, you do not consider anything after your decimal. So if you divide 15 by 2, everything our decimal will be considered as 0 only. So we'll lose these values, right? So keep it in mind that whenever I'm dividing here, I'm talking about your integer type only. Alright, so yeah, let me remove this from here. Okay, so now let's go to our conversion part. Alright. So to convert 6 into your binary in binary form, what we'll do is we'll take the number here. I'll take 6. Now what I'll do is I'll keep on dividing it with 2 and take the remainder as my answer. Now how will do and store that? I'll teach you how. So like let's first divide it with 2. After dividing it with 2, I'll get 3, and the remainder is 0, right? I am storing the remainder here. This is my remainder. This is what I'm dividing with, and this is the number. 6 divided by 2 becomes 3. Now I'll divide it again by 2. It becomes 1, and I'll divide again by 2. It becomes 0. I'll keep on dividing until I get here 0. So now what happens? 3 divided by 2, I get a remainder as 1. 1 divided by 2, I get a remainder as 1. Alright.
So this is my binary form, and how do I represent it? I'll take it from bottom to up and represent it here. So first is 1, then we have got another 1, and then we have got a 0. Alright, so this is my binary representation of 6. Now let's do that for the for same for 19. So I have 19 here, and let's do the same process. So first is divided by 2, we get 9. Then we again divide it by 2, and yeah, here we are getting remainder as 1. Then we divide it by 2, we get the remainder as 1 again. Then we get a 4, and then we divide it by 2 again, and we get a remainder as 0. Then we get 2, then we again divide it by 2, we get 1. And at the end, we'll again divide it by 2 and get finally 0. Alright, so yeah, we'll get a 0 here. Here we'll get the 0, and here at the end we get a 1. Again, what did we do? Uh, we were taking from bottom to top. Sorry for that. Yeah, we'll take from bottom to top, and our binary conversion looks like 10011. So this is my binary conversion, like binary form of 19, and this is for binary form of 6. Now I'll convert them back to binary and check if the process we have done in the binary form is true or not. Alright, so here we go. The binary form for 6 was 110, but how do I confirm that? Alright, so what happens is in binary form now, all the places are defined as the power of 2. So the first place is defined as power of 0, 2 to the power 0, then 2 to the power 1, then 2 to the power 2, and so on. So if I see, okay, so another thing is if I want to consider them or not, then we go by the rule of zeros or 1. So if we have a 0, I do not consider that. If we have a 1, I'll consider that. Alright, so if I simplify that, so we have got a 0 here, I do not consider that. We have got a 1 here, so I'll consider that. So the places 2 to the power 1, I'll take a 2 here. So now the another place also has a 1. I'll say, okay, the place has 2 to the power 2, I'll again take it here. So we have got a 4 and 2, and we'll add them at the end. So what do we get? We get a 6. So I've confirmed this is the, like, this is our this is the form of 6, like this is the binary form of 6. Now I'll go for 19. So what was the form for 19? 10011. All right, so now that is 100 and double one. So this is the binary conversion for 19. Let us see if it is true or not. So let me use another pen, better clarity. All right, so this place is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2, this is 2 to the power 3, and this is 2 to the power 4. All right, so now let's see which of them are zeros or 1. This is 1, so I'll take that. Okay, this is my 1. Now this is again a 1, so I'll take the position. This is 2, this is 0, I'll not consider it. So it's 0, this is 0, I'll not consider this one also, so I'll take it as 0. Now this portion has got a 1, so 2 to the power 4 is your 16, so I'll consider them. Now sorry for that. So what do we do? Got to do is just add up all of them. So 16 plus 2 plus 1 equals to 19. So yes, we have verified that these are the conversions for 6 and 9 respectively. So we finally know that, okay, how do we like store your numbers in your like for your integers, but how do we do that for your characters and symbols, right? Because okay, we can easily convert the numbers to binary, but how, what about your characters? So the characters are converted in a similar way. Now how so? There is a like international norm for your defining your character. So we have got that as ASCII. So every character has an ASCII value. So if I say for small a, the small a has an ASCII value of 97, small b has an ASCII value of 98, and so on. up till your z has an ASCII value of 122. So if you try to store a, so we'll do in the similar way for the above numbers. So we'll simply write the binary conversion for 97 and store it. But you might have a doubt like, okay, now the numbers and the characters have same representation. So how do we determine that? So then your int and char comes into play. So if for the same for the same binary form, if we have the data type as int, then I can say, yeah, okay, it like the data type is int, so this is of integer type, this is simply 97. Otherwise, if the 97 has your data type as character, so I can say, okay, this one is your a. So the ASCII value has for everything. For your capital A, it starts with 65, and it goes till, I guess, 65 plus it goes till your 90. All right, and for add rate and hashtags also, there are also ASCII value for them. You can read it later on. So that is how we store your posit characters. All right, we have known for your numbers and your characters, but there is another thing. This is the way for storing your positive numbers. For storing any negative numbers, there is another way to do that. We do not store them normally. All right. So for storing them, we have got a way of complements, and I'll tell you about them. All right. So converting a negative number is also simple. All you need to do is first normally convert it to binary form. Just treat it as a positive number. Then you need to do two another steps which are easier. So I'll take the example of 19 only. So let us see what was its binary form. 10011. All right. So I'll take for minus 19. First, all you need to do is take its binary form 10011. This is its binary form. Now you need to find its ones complement. So what is your ones complement? It is just simply what you need to do is just reverse like all your bits. Like if it is 1, then make it 0, and if it is 0, then make it 1. All right. So yeah, I need to tell you one another thing, that it's a representation in what I have represented you in terms of 5 bits. But if you take a real life example, that if you are storing an int, then there will be 32 bits to store it, right? So there will be around 32 zeros, sorry, 32 27 zeros, then 10011. So this is the actual representation of your minus 19. All right. So now if you want to store your um, uh, minus 19, so suppose we have something like this. Now you need to find a ones complement. So what will happen is, suppose I'll take it here only. All right. So what will happen is, I'll reverse all of these bits. All right. So the zeros will turn to your ones. So I'll have 1 1 1 1 up till your 27 ones. Then I'll have a zero here. Then double one, and then double zero. So this is your ones complement. It is still not complete. Remember, it is still not complete. I'll just remove these fillers. Like, it may distract you or confuse you. Yeah. So this is my ones complement. All right. Now I need to convert it to twos complement. Twos complement. So what do you need to do for twos complement? Nothing. Just simply add a one. So what will happen? I'll take all of these ones. Alright, 27 ones, then I'll have a 0, double one, 0, and a 1 at the end. So this is the representation of minus 19. So what you had to do, convert to binary, then to ones complement, then to twos complement. All right. And how does a compiler determine if it is like a negative number or not? It just sees at the first index. If the first index is 1, then it is negative. If the first index is 0, then it is positive. All right. Yeah, we have an extra bit for that. We always have an extra bit for that. All right. So we have now learned how do we store your variables in your memory. So next step is to learn about tokens. So yeah, this is the last part for this video. So we'll go to tokens and wrap it up fast. Alright, so we have got six tokens in total: keywords, operators, identifiers, constants, strings, and your special symbols. Alright, so first we'll begin with keywords. So keywords are nothing but your reserved words which C++ has, such as your class, return, and your if statements. We'll learn more about if and else statement. Just remember these are your conditional statements. This determine your flow of code. All right. Next are your identifiers. What are identifiers? These are simply you can say variables or the name of functions. Like your functions also have names because you don't know which function to call when and all. So we got names for them too. All right, then comes your we have done keywords, we are done with identifiers. Next are our constants. We have also done learned about constant that the variables which do not change over time uh, after we have declared them. These are known as constants. Now comes our operators. Operators are like the symbols which are used for operation, plus, minus, multiplication, division, and it is binary. It is your assignment. We'll learn about these in another video. Alright, now comes your special symbols. We have these braces which are part of your functions, and these brackets which are part of your methods. Alright, now comments. Yeah. So if you want to write comments in C++, you just simply write two slashes and then write whatever you want to. These will be treated as comments. Alright, and uh, the storage part and the conversion of a decimal to a bits, we'll also do it in another video. But if you want to see a variable like initialization, declaration, and manipulation, I'll just quickly show you how we can do that. So suppose I have this int of age. I'll keep it as 10. Alright, I'll print quickly this age and endl. Then what I'll do, I'll manipulate this age. This is your storage. These are comments. See how I just use two backslashes, and whatever I wrote, it does not it. So basically what I recommend, these are your whatever you write, and your compiler just ignores them. These are ignored by your C++. Whatever you write after this is ignored by your C++. So this is your uh, first one was storage, another one was retrieval. Now I'll manipulate it. I have initialized at 10. I'll say okay, age becomes 30. Now let us see if this will run or not. Age is 30. And this was your storage retrieval manipulation. And simply at then we'll print and check if we have successfully manipulated it or not. So enter and let's run. We have not taken inputs. I have also removed the input from there. So running it, I can. Okay. Okay, yeah, fine. So the age was 10 before, we have gotten the output as 10. The age was 30, we have gotten the output as 30. You can ignore this field, like this is used for competitive programming to match your expected output and received output. You can ignore it for now, but this is really helpful when you are trying to run your code faster, and you can simply just check your expected and received output are same or not. So I recommend using this uh, extensions to you all. So yeah, that's it for the video. In the next video we'll learn about these operators, all of these operators in detail with their uh, implementation and all. So yeah, thank you for watching this video till now.